In this discussion video, we will do some definite integrals practice. So I want to look at this problem, which is from worksheet 14, and I want to first give you 5 minutes to try parts A and F of this question. So pause the video in 4, 3, 2, 1, pause it and try these for 5 total minutes. All right, so hopefully you did that. Hopefully you paused them and tried them for about 5 total minutes. Let's talk about them now. So for part A, we can handle this using U-substitution. If I let U be the denominator, x squared minus 1, du is going to be 2x dx. And I know that's going to be nice because I see this up to a constant multiple in my integral. I see x dx in here. And that's just du just off by this factor of 2. And that's one of our tip-offs that U sub is going to work. Okay, so let's isolate the dx and get du over 2x equals dx. Okay, so before I plug in, because I have these limits of integration, these are in terms of the variable x right now. So there are 2 ways we could handle those limits of integration when we do a U sub. So I want to talk about both of those. Method 1 is we could change those limits of integration to be in terms of the new variable u. So what does that look like? So my lower limit is x equals 3. So as a u value, I would plug that into my substitution, plugging in 3 for x. I get 3 squared minus 1, which is 8. If I do the same thing for x equals 5, and we plug that in, we'll get u equals 5 squared minus 1, which is 24. Okay, so I'm going to put a little bubble around this. This is what my limits of integration are going to change to as u values. All right, so our integral will become, the lower limit becomes 8, the upper limit becomes 24 as u values. Then I have this x on the numerator, the denominator becomes u, and then dx is du over 2x. All right, so the x's cancel. I can pull the 2 in front, and I get 1/2 integral from 8 to 24 of 1 over u du. So that antiderivative, that one's not bad. I just get 1/2, whoops, 1/2 times ln absolute value of u. Then I got to plug in the 24. So this gives me 1/2 ln. I would get absolute value of 24, but 24 is already positive, so I don't need an absolute value. I could just write that as a parentheses, because the absolute value of 24 is just 24. And then minus, if I plug in 8, I get 1/2 ln, same thing. Absolute value of 8 is just 8. So I can just write that in parentheses. And that's our answer. Okay, so there's one other way we could handle U sub questions with these limits of integration. So I want to review that as well. So method 2 is going to involve not changing our limits. We won't change the limits. So with our integral, once we did the U sub, we had x over u times du over 2x. So what if we just kept our limits of integration as x values? It was a 3 and a 5. If we do that, we have to indicate that these are x values. So this is x equals 3, and this is x equals 5. Otherwise, once I convert my integral in terms of u, it'll look like those are u values. And that's misleading. So this is an important notational thing to do. Okay, so if I simplify, this becomes 1/2 integral of 1 over u du. Okay, and I gotta write x equals 3, and I gotta write x equals 5. All right, and now I do my antiderivative, so I get 1/2 ln absolute value of u. Gotta put my vertical line, and now I'm gonna plug in x equals 3 and x equals 5. And we have to keep writing it like this. We gotta keep writing x equals stuff until substituting. I'm just going to write subbing for substituting. Subbing back for the x. Okay, so we got to keep writing this stuff, this notational thing that we're doing, these values, until once I have my antiderivative, right now it's in terms of u, I got to get it back in terms of x. Okay, so I'm going to now plug back in. I get 1/2 ln absolute value, and u, we said it was x squared minus 1. Now that it's back in terms of x, now I get to just write 3 and 5. Okay. All right, so if I plug in 5, I'll get 1/2 ln. It'll be 24, and I don't need the absolute values because this is positive. And then minus 1/2 ln. When I plug in 3, I'll get 8. And that's positive, so I don't need the absolute values. So we get the same answer this way. Alrighty, let's do part F. So in F, we have the integral from -5 to +5 of the square root of 25 minus x squared. For this question, I'd encourage you to try it if you haven't yet. But U-sub, again, definitely pause it if you haven't tried it. Give yourself a minute, 2 minutes to try it if you haven't. That's going to be important for this one. Okay, I'm not going to count it down or anything, but I'm going to trust that you paused it. All right, so U-sub won't help for this. I'd encourage you to try it if you haven't, but it won't help. So we need one of our previous ways. We need some other way to be able to handle this definite integral. This is not a function that I just know the antiderivative of. There is a way to find the antiderivative of this function, which you'll cover in Math 1B, in Calculus 2, the next calculus class. It involves something called trig substitution, but we don't know that yet. Okay, so we have to use one of our other ways for evaluating definite integrals, which are things like, limit of Riemann sums. But that's usually super, super tedious. We usually never want to do that unless a problem specifically says, do a limit of Riemann sums. And the other way is, if the function has a graph that we know, and it's things like lines or circles, then we could just use area formulas from geometry. And this function has a graph that we know. At least hopefully, we've seen it before. This is a semicircle graph. So let's graph it. Let's graph this function, y equals square root of 25 minus x squared. So if I draw my axes, that 25, this represents my radius squared. And we've seen before in lecture videos when we first talked about this that the center of this is going to be the origin. It's going to have a radius of 5, so it's going to go 5 in each direction. But because y is the square root of something, when I square root something, the output can't be negative. So my y values are non-negative here, which makes this be the upper half of the circle, just the part that has non-negative y values. So that's going to be 5 up there. So our question is asking for the integral from -5 to +5. If I shade in that area from -5, when x is -5 here, to when x is +5, I got to shade all of this. So it's going to be the whole semicircle. Okay, so this is the area of that semicircle. And if we work that out, that is 1/2 pi times radius squared, 5 squared. And this is 25 pi over 2. And that's our answer.